we're going to solve an example problem involving motion in a straight line with different phases of acceleration. Let's read the problem. We need to find two things. 1. The total distance traveled from point A to point D in terms of t. 2. The value of t such that the total displacement from A to D equals 300 meters. To solve this problem, we'll analyze each segment of the journey separately. Let's visualize the journey. We have 4 points, A, B, C, and D. From point A to point B, the particle accelerates uniformly at 4 meters per second squared for 5 seconds. From B to C, it moves with constant velocity for t seconds. And finally, from C to D, it decelerates uniformly at 2 meters per second squared until stopping after 10 seconds. Let's analyze the first segment from A to B. We know that for uniformly accelerated motion, we can use the equation distance equals initial velocity times time plus 1/2 acceleration times time squared. Since the particle starts from rest, initial velocity is 0. Acceleration is 4 meters per second squared, and time is 5 seconds. Plugging these values in, we get distance equals 1/2 times 4 meters per second squared times 5 seconds squared, which equals 2 times 25, giving us 50 meters for the distance from A to B. Using V equals U plus AT, the final velocity at point B is 0 plus 4 times 5, which equals 20 meters per second. Now, let's analyze the second segment from B to C. For motion with constant velocity, the distance is simply velocity times time. The velocity is 20 meters per second, as we just calculated, and the time is t seconds. So, the distance from B to C equals 20 times t, or 20 t meters. Finally, let's analyze the third segment, from C to D. For uniformly decelerated motion, we again use the equation distance equals initial velocity times time plus 1/2 acceleration times time squared. The initial velocity is 20 meters per second. The acceleration is -2 meters per second squared deceleration, and the time is 10 seconds. Plugging these values in, we get distance equals 20 times 10 plus 1/2 times -2 times 10 squared, which is 200 minus 100, giving us 100 meters for the distance from C to D. Now we can calculate the total distance traveled from A to D. It's simply the sum of all 3 segments, SAB plus SBC plus SCD, which equals 50 plus 20t plus 100, giving us 150 plus 20t meters. So, the answer to the first part of our question is the total distance traveled is 150 plus 20t meters. For the second part of our question, we need to find the value of t such that the total displacement from A to D equals 300 meters. Since our motion is along a straight line in one direction, the total displacement equals the total distance. Setting the total distance equal to 300 meters, 150 plus 20t equals 300. Subtracting 150 from both sides, 20t equals 150. Dividing both sides by 20, t equals 7.5 seconds. So, the answer to the second part is t equals 7.5 seconds. Let's visualize this motion with actual distances. Here's a distance-time graph of the entire journey. In the first 5 seconds, the particle accelerates and travels 50 meters. Then, for the next 7.5 seconds, it moves at a constant velocity and covers 20 times 7.5, which is 150 meters. Finally, it decelerates for 10 seconds and covers an additional 100 meters. The total distance traveled is 300 meters as required